Hello everyone. This is homework 26, continuation of factoring trinomials, but now we refer to this as being advanced. So recall that a quadratic trinomial has this general form: ax squared plus bx plus c. A is not 0, we're assuming a, b, and c are real numbers. And remember, if a were 0, then it wouldn't be quadratic, because quadratic is squared term. And if that were gone, then it would be linear, because you'd only have an x and a constant. We looked at the basic case last time where a was 1. So if a is 1, it just takes the form of x squared plus bx plus c. And we had a general rule that works only when a is 1. And that's when we look for two numbers that multiply to give us c and add to give us b. But again, that only works when a is 1. So that's why when I was showing you the solutions to the problems in homework 25, I was pretty much focusing on the trial and error method, the reverse FOIL idea. We could use factor by grouping. That's something we looked at when we factored 4-term polynomial, but I'm going to consider factor by grouping only for 4-term polynomials. For quadratic polynomials, I'm going to suggest trial and error. And when a is not 1, we can't use the rule for multiplying to give us c that add to give us b. We have to literally reverse the FOIL method. So here's a procedure. We're going to set up the factorization of to be the product of two binomials once again, but where the first terms are going to produce ax squared. So rather than just x squared, they have to multiply to give us ax squared. And that's what causes the little imbalance, so that the rule for when a equals 1 does not apply. So after we set that up, we're going to force the product of the last terms, just as we did using the trial and error method in the last homework. And we're going to check that the outers and inners produce the bx term. So in these examples, we're given one of the factors. So this kind of is a hint as to how to proceed. So we're going to complete the factorization and check using FOIL. So this gets us warmed up to the idea. So we're given that 3x plus 11 is a factor, and we know that we have a binomial here that's a factor. So the idea is that, once again, the first term of the quadratic trinomial comes from the product of the first terms in the product of the two binomials. So in order for this first product to give us 3x squared, we don't really have a choice here. If this is 3x, then for this product, which is again the product of the first in FOIL, to give us 3x squared, our only choice is x. And then we could use some of the ideas that we had in the past regarding the signs. If the signs of the terms, if the sign of the constant term was positive, remember the signs of the terms in the two binomials will be the same. And that's based on whatever the sign of the linear term was. And so in this case, they're both going to be positive. Now, notice that we don't really have much of a choice when we decide what the product of the last is going to be. Because, and I'm going to make my last terms here. I'm going to leave this little product for the inners. I know that's 11x, that's the inner terms. In the product of the last. We don't really have a choice. If this is an 11, The only thing we could put here would be the 1. So we'll check by FOIL. And that would be the product of the last. So the first gave us 3x times x, or 3x squared. The outer, so that's this product, 3x times 1 plus 3x. The inner product, 11 times x plus 11x. And the last product, 11 times 1, or plus 11. But, sorry, I wasn't showing you that. Okay, so give you a second to catch up. And then, as we've noticed quite often, the outers and inners combine. We recopy the 3x squared, 3x combined with 11x, gives us 14x. And then the constant term we just bring down, and we see that that checks. So again, the first term, last term is the product of the last, and then the middle term is a combination of the outers and the inners. But notice here how the factors of 11 are really just 11 times 1. They don't add to 14. Okay, and that's because of the weight of these first factors, the fact that this is 3x rather than just x. So that's why the method of factors that multiply to give you the c and add to give you b do not work. Okay, so in this case, again, we're getting warmed up to the concept. They're giving us a hint. And we have to think of reversing the FOIL method. Fortunately, this is 5x squared and this is 5x, so the only thing that the first term of this second binomial could be is x, to give us the product of 5x squared. And then similarly, well, again with the signs, this is a positive 3, so these signs in the binomials must be the same. And since this middle term is positive, this sign must be positive as well. Now, we're going to calculate the outers and the inners to check. I'll save that though, but I'll just write them in here. But see, now we want to force the last to give us a product of positive 3. And it looks like we don't have a choice again. It must be a 1. And that would be the last. So checking by FOIL, product of the first, 5x times x, 5x squared. Product of the outers, 5x times 1 plus 5x. Product of the inners, 3x times x plus 3x. And the product of the last, 3 times 1 plus 3. Then we recopy the 5x squared term. We can combine the outers and inners. Positive 5x and positive 3x give positive 8x. Bring down the constant term plus 3, and that completes the check. Okay, so again, we're given a situation where there's not much of a choice. They're telling us 3x plus 4 is a factor. And for the product of the first to give us 3x squared, we need an x again. And so let me label that as F. Worry about the O and the I in a minute. And we'll force the last ones. And the last are positive again. Both terms must be positive for the same reasoning as the first two examples. And in order to multiply 4 times something to get 8, looks like we needed 2. And so our check, product of the first, 3x times x, 3x squared. Product of the outer, 3x times 2, 6x. Product of the inner, 4 times x plus 4x. And the product of the last, 4 times 2 plus 8. Recopy the 3x squared, Combine the outers and inners again. 6x and 4x combine to give plus 10x, and bring down the constant of 8, and once again that completes the check. Okay, so here, because they're giving us this one factor, it makes our choices quite a bit easier. Because again, to get the product of the first here, now I've got 5x, so the only way to get 50 squared is for this first term to be 10x. And then that forces the product of the first to give us 50x squared. Now we force the product of the last. Now this is already negative. Well, let's say this first. We know that because the sign of the constant term is negative, that these must be opposite signs. So therefore, in the second binomial, it has to be plus. And that can be discerned as well because the product of the last, -1 times whatever, has to give us a -3. And it looks like we don't have a choice. That has to be a 3 because that's the only factors of 3 are 1 and 3. So let's check with FOIL. 5x times 10x, 50x squared. For the product of the first, the outers give us 5x times +3 plus 15x. The inners give us -1 times 10x, or -10x. And the last, -1 times 3, or -3. Recopying the 50x squared, and combining the outers and the inners, 15x and -10x, we get +5x, and bring down the constant, and that completes the check. So now our job is going to be, what if they don't give us a hint? Okay? And so that's where we have to sometimes use a little thought, do a little trial and error. Sometimes things don't work out perfectly, but I'm going to squeeze in the solution here so I know that this factors as the product of two binomials, and because the first term is 3x squared, we're going to split it up into 3x and x, because that's the only way for that product to give us 3x squared. So we've forced the first terms. Now let's take care of the signs. The constant term is positive, the middle term is positive, so both signs are positive. And now we guess. And you have a bunch of choices. You're still going to use the factors of 20. Okay, so here's our choices. We still need the factors of 20, because these last terms have to multiply to give us 20. So I know that they're based on the signs. I'm not even going to worry about the negatives. So we have a choice of 1 and 20, 2 and 10. 3 doesn't go in 20, 4 does 5 times, so 4 and 5. Now, when you consider trial and error, let me get some scrap paper here. If I did the 3x and the x, okay, I'm going to do all the wrong ones first, and then we'll finally get the right one. But just to show you the idea, I know these both must be positive, so we've got a 1 and a 20 as a possibility. Well, the inners would give 1x, the outers 60x, that gives us 61x. We're looking for 19x, so that's no good. But maybe if you switched them around, the 1 and the 20, it would work. But let's see, that would give us 20x. This would give, you don't have to write all this down, just making the point. Outers give us 3x, that's 23x. So that doesn't work. So then maybe it's the 2 and the 10. So I'm going to try +2 and +10. inners give 2x, outers 30x, combined 32x. That's not it. So maybe you switch them around. Maybe it's the 10 with the 3x and the 2 with the x. And so inners give 10x, outers 6x. That gives us 6x. That's wrong as well. So it looks like the only other choices are 4 and 5. So 3x and x, both positive, in between. And let me go with I want to get it wrong. I'm going to go with the 4 with the x and the 5 with the 3x. Then the inners give 5x, the outers give 12x, that gives us 17x. So that's wrong. So then the final one that actually does work is if we switch those around and we put the 3x, the 4 with the 3x, and the 5 with the x. And then we'll check this by foiling. But really all you have to do is check the outers and the inners. We get the 4x. And 15x, which combined to give the 19x. And that was what we were looking for. So the correct factorization, 3x plus 4 and x plus 5. See, we really don't have to check the first and the last because we forced those, right? Forced the product of the first to be 3x times x, which gave us x squared, and the product of the last to give 4 times 5, which is 20. Okay, so on to the second example. Once again, set up product of 2 binomials. And since the leading coefficient is 3x squared, the only way to split it up would be a 3x and an x. Again, we do need the factors of 13. Alright, now the factors of a negative 13, that is. And we know that these signs have to be opposite. So one has to be positive, one negative. And we only have one choice. A positive 1 and a negative. We only have 2 choices, that is. Positive 1 and a negative 13, or a negative 1 and a positive 13. So off to the side, let me try the wrong one. Okay, first off, if I want, let me put the 13 here. Let me just guess at the signs. I'm going to guess positive. I'm going to guess negative and positive is what I want to guess. Okay, I'm doing this on purpose. That is getting it wrong. Negative and positive. And again, you don't have to write this down, or you could, it's up to you, but I'm going to scrap paper to do it. So I want to force this last product to be negative 13, so if I put the negative 13 there, a positive 1 would go there. Now that gives us negative 13x and positive 3x for the outers and the inners, which combine to give us negative 10x, and that's not what we're looking for. So the only other choice is to switch around the 13 and the 1. So if I put the 1 with the 3x, let me leave that as negative for now, and put the 13 with the x. Then the inner product's negative 1x, and the outer product is positive 39x, which combine to give us a positive 38x. But we were looking for a negative 38x, so therefore we just switched the signs between the two terms in the binomial. So the one goes with the 3x, but it's positive, and the negative 13, and the 13 goes with the x, but that's negative. And then we can verify, once again, that the product of the inners is plus 1x, the outer product, negative 39x, which combine give negative 38x, and that checks because that's what the middle term is. So the correct factorization, 3x plus 1 and x minus 13. So we still need the factors, but the rule of adding to give the middle term does not work. Alright, when the leading coefficients prime at least, like the 3, or in this case a 7, at least it makes it a little bit easier. You're going to see this more in Math 110 when you move on, and that's when you'll deal with a lot of the other situations, which are sometimes a little bit more complicated when the leading coefficient is not 1. But here we're pretty much forced to have a 7b and a b. That's the only way to break up a 7b squared. Now I know the signs need to be opposite, so one needs to be positive, one needs to be negative, and I've got to get some factors of negative 12. So 1 negative 12, negative 1 and 12, let's see, 2 and 6, so 2 negative 6, negative 2, 6, and 3 and 4, so 3 negative 4, negative 3, 4, and that's it. Now, let me show some work aside here before we make our final guess. So we've got a 7b and a b. Just guess at the signs. That's why it's called trial and error. You know, maybe in the future when you try a lot of these, you'll guess correctly, but if not, we saw you just switch them at the end, as long as we get the right magnitude, the right number. So let me guess positive and negative. I don't know. But I do know that this final product has to be 12. So I'm going to go with a 4 and a 3 and see if I get lucky. Plus 4b, negative 21b. Now that gave us negative 17b. So that's not it. Maybe if I switch the 4 and the 3. So 7b plus 4, or plus 3. I'll leave the signs the same for now. And b plus 4, b minus 4, excuse me. And let's check the inners and the outers. So the inner product plus 3b, the outer product negative 28b, combined to give negative 25b, and that checks. That's what we're looking for. So it looks like 7b plus 3 and b minus 4. Okay, so trial and error is the way I'd like you to consider. You're not going to get a lot of these on the exam where the leading coefficient is not 1, but there will be 1 or 2. But just like before, greatest common factor first. When you're looking at this one, it first looks like nothing's common, well, at least between the coefficients, but definitely an x is common between the variables. Alright, remember we reverse distribute So x times what gives 4x cubed? That'd be 4x squared. X times what gives negative 9x squared? That's negative 9x. And x times what gives negative 9x, and that would just be a negative 9. Okay, and so in terms of the factorization, product of two binomials, I'm going to go to some scrap paper. And I want to show you that you don't have to write this down because I'm going to do all the wrong ones. Could be a bunch of possibilities because I'm looking at factors of negative 9, this constant term. So 1 negative 9, negative 1 9, and 3 and 3. So 3 negative 3, vice versa. So at least there's only two things to try. But there is also two things to try for the factors of 4x squared. So we have to consider factors of 4 as well. And they're just 1 and 4 or 2 and 2. Now both would be positive because we're talking about the first term. So it could be 2x split up as 2x and 2x. Now again, you don't have to write this down because I want to show all the ones that don't work and then we'll get the one that does finally. But it could be 2x and 2x because that would give us the 4x squared for the product of the first. And now we need a 9 in here. Well, let's see. Signs are going to be opposite because this is negative, so let's just make one negative and one positive. And a 9 and a 1. So that gives negative 2x, is my guess, 9 and 1. That gives negative 2x, positive 9x, combines, give positive 7x. That's not it. So maybe switch them around. Well, it wouldn't help switching them around because they're both 2's. So they weight the same. So the only other possibility would be 3's. So 2x minus 3 and a 2x plus 3. And that gives minus 6x plus 6x. That's 0. 0x if you like. So that's not it. So therefore it can't be 2x because we've exhausted all the possibilities. So it has to be a 4x and an x. And so now, again continuing on scrap paper, if I do a 4x and an x, my choices are 1 and 9. Now I know they're opposites, so let me just once again I guess negative and positive. If I put the 1 here and the 9 here, it gives negative 1x, positive 36, or excuse me, negative 9x. No, I'm sorry, positive 36x. I was right the first time. Which combined to give positive 35x. So that's not it. So the only other thing left, well, we could switch the 9 and the 1, I suppose. See, in this case, that would make a difference. As opposed to when we had the 2's here and it didn't make a difference switching them because they were weighted the same. This gives negative 9x, positive 4x, negative 5x, and that's not it. We want a negative 9x here as the middle term. So it looks like the only thing left is a 4x and a 3. So 4x minus 3 and x plus 3. So the 3 and the 3 is the only choice. And the inner one gives negative 3x. The outer, positive 12x. They combine to give us to give us positive 9x. And the sign's wrong. We need a negative 9x. So just switch the signs. So that means 4x instead of minus 3, plus 3. And x instead of plus 3, minus 3. And you could double check that by taking the inner and outer products again. Gives plus 3x minus 12x combined to give minus 9x, which checks. So the correct factorization, x, 4x plus 3, and x minus 3. Alright, one last example. Here, we'll go with the greatest common factor first. Oh, I should have said that here, right? Greatest common factor is x. I didn't write it. We obviously said it, but we didn't write it. Okay, between the coefficients 2, 10, and 50, or excuse me, 4, 10, and 50, a 2's in common. Between the y variables, least power is y. So 2y is our greatest common factor. So if we reverse multiply, 2y times what gives 4y squared. Looks like we'll need a 2 and a y. Okay, you could recopy the negative. 2 times what gives 10, that's 5. And y times what gives y squared. We need another y. Oh, this is, I'm sorry, 2y squared, right? We need a y squared there because we have to add these exponents to get 3. Okay, and then minus 5y we just discerned, and then minus to get the 50, we need a 25. And the y is already there, so we don't need anything else but that constant of 25. Okay, so assuming this factors as the product of two binomials, we have no choice but to try a 2y and a y. And also, 25 and 1, probably unlikely, okay? But you could try it. But the only other thing I can go for is a 5 and a 5. Now, if you don't fill in the signs, you can kind of think. Let's just try to think mentally. This gives us positive. This gives us 5y. This will give us 10y. We'd want the 10y to be a negative and the 5y to be a positive. And then that'll work. This gives plus 5y for the inners, minus 10y for the outers, combines to give negative 5y, and it checks. So the correct factorization here, the 2y is part of the factors. And then we have 2y plus 5 and y minus 5. Okay, so that's advanced. You'll do a lot more of that in Math 110. I'm not going to give you too many of those on the exam, but you do need to know it. So that's the end of homework 26. So we'll come back and talk about homework 27.